Welcome back to Algebra 1, Chapter 12, Section 2 in this book. We have almost made it to the end. We're in the very last chapter. And like I told you, some of this is really Algebra 2 stuff. Some of this is easy, and I want you to know it. I'll tell you which is which. Okay, so what we're talking about is something that sounds way cooler than it is. Radical expressions. It sounds like somebody from the 80s. Rad, dude. Let's go surfing. Anyway. Okay, so these are called radical expressions because they have a radical in them, the square root sign. So that's what it is. Now then, when you have this, you can put this in your calculator, square root of 2 plus 3 times the square root of 2, and you would get a weird decimal that is considered incorrect. Why is it incorrect? Your calculator just told it to you. And it's because there's a difference between equals and approximately equals. If you put it in your calculator, it will give you a weird decimal that is approximately equals. It's rounded off. And it is more correct to leave it as a radical, and then it's actually equals instead of approximately equals. So here is an expression. How do you do it? Well, if they're plus or minus, is what we're going to talk about first. If they're plus or minus, to be able to add or subtract them, they have to have the same exact radical. It's like a unit. You can't add 9 degrees Celsius plus 4 meters. It doesn't make sense. One's a temperature and the other one is a distance. You can't add them together. To add or subtract things, they have to have the same units, and you can think of these like a unit. Okay? There is an understood one here. They have the same radical, so I can add them. 1 times the square root of 2 plus 3 times the square root of 2 is 1 plus 3 is 4, and my unit, you can think of it like that, is square root of 2. So that's the answer. How about this one? There's an understood one here. 1 of these minus 3 of these is negative 2 of these. Does that make sense? Just don't even think of it as a radical. Just think of it as a unit. So 1 minus 3 is negative 2. How about this one? It's got a 5. So that one can't go, but these can. 2 of these minus 6 of these is, did I write that here? Oh, I didn't. Hold on. Ooh, that's a new problem. Is negative 4 times the square root of 2 plus square root of 5. And that's all you do. You leave that one alone. It can't be gathered up with anybody, but we can gather these terms. We should sing about it. Gathered up our terms. Okay? So 2 minus 6 is negative 4. You leave the 5 alone. What about this one? 4 times the square root of 3 minus the square root of 27. It appears we can do nothing, but wait. We can simplify this. We can see if anybody can get out of jail and see if we can do something. 27 is 3 times 9, and 9 is 3 times 3. This one gets dissolved in acid, that one gets out, that one stays in jail. So this square root of 27 is 3 times the square root of 3. Now we can do it. 4 times the square root of 3 minus 3 times the square root of 3 is 1 times the square root of 3, but the cool kids make it just understood, and then we write it just square root of 3, because we're the cool kids. Alright, how about that one? Multiple, so adding and subtracting, they have to have the same unit. But remember, multiplying and dividing frees us. We can pretty much do whatever we want. So square root of 2 times square root of 8 is square root of 16, because 2 times 8 is 16, and they're still in jail. They're under the radical. But 16 is made out of 4 times 4. One gets dissolved in acid, and one gets out, and that's the answer. Now you could actually do this one on your calculator. Square root of 2 times square root of 8, it would tell you 4. Notice, it's really plus or minus 4, but I told you your book is inconsistent, and they want it to just be positive 4 this time. How about this? Well, parentheses, what do? Distributive property. 5 times the square root of 2 and square root of 2 times 3. So 5 times the square root of 2, you write it this way. Square root of 2 times square root of 3 is square root of 6. And that's all you do. We're done there. What about this one, this squared? Well, that means there's 2 of them. So we need to do 1 times 1 is 1. 1 times square root of 5 is 1 times the square root of 5. Square root of 5 times 1 is 1 times the square root of 5. And square root of 5 times square root of 5, now those are twins, so the 5 gets out. So that's the same thing. Square root of 5 times square root of 5 is the same thing as the square root of 25, which is made out of 5 times 5. 1 gets dissolved, 1 gets out. Okay? And then we can gather up these terms because they're the same. 1 square root of 5 plus another square root of 5 is 2 times the square root of 5. And we can gather up these. 1 plus 5 is 6. So that's the answer. What about this one if it's letters? We can still do it. A times A is A squared. These, because 1's plus and 1's minus, are going to cancel each other out. And square root of B times square root of B is B squared. That's twins. 1 gets out, 1 gets dissolved. So that's the answer, it's just letters. Now, this next thing is something that is in the high school math books, but from what I hear from my college-age sons, is it's not done anymore. There's a math etiquette rule that says you are not allowed to have a radical in the denominator. Oh, the rudeness! The Emily Post of Math is so upset seeing that. That is so rude, so rude. So how you get it out is, remember, you're allowed to do anything you want as long as you do it to the numerator and denominator. And what we want to do is multiply by the square root of 5. See here? 2 square root of 5's multiplied is 5. It gets out. And then 3 times the square root of 5 just stays in the numerator. So this is considered more polite. But if it's me, and I'm grading it, and that is your answer, I accept it. I think that math etiquette rule is out of style and nobody follows it anymore. Like how people don't say thee and thou anymore either. Now, but where you do see it is when you learn trig, there's going to be trig charts that have weird things on it because they're following this rule. Just put that back in your head somewhere. Now, if you have something like this, where it turns out the answers of this, the factors of it, the solutions are 2 plus or minus the square root of 3. I don't want you to be able to do that yet, but I would like you to be able to use a computer program on your calculator that will do it for you. The best one to use is one I have called discrimi. It makes you put in the A, B, and C term twice. The term for A here is 1. It's an understood 1. So you hit discrimi and it'll say, what is A? You put 1. B, -4. C, 1. You hit enter and it'll tell you the discriminant is 12. We don't want the discriminant, we want the answers, so you put it in again. A is 1, B is -4, C is 1, and it will tell you the answer. Now, on the newer calculators, if you're doing discrimi, it scrolls by real fast, and a lot of times it goes so fast it's hard to see that there's 2 answers. 2 plus the square root of 3, and 2 minus the square root of 3. On the older ones, it goes slow, and you can see both of them there. But anyway, I want you to have a program in your calculator that will give you the answer to solutions of a quadratic equation with the radical and not just as a decimal. So if you don't have one, I want you to get one or find one. And if you live near me, I will bring your calculator, I will use my cables, and I'll give you discrimi. Also, A quad is a real good one, but it would give you a weird decimal. We don't want the weird decimal. We want it still in the radical form. Alright? Because it's equals versus approximately equals. Alright? Come back for 12.3. It'll be great. Math is great.